Today we've got a job from an end user, and he's a paramedic. So whilst he's running around saving people's lives, we'll run around and actually do his radio next day. Because we haven't got any customer repairs in this moment, but there's a lot on the way. This is a Midland 77805, and he says he hasn't got a display on it. I hope he hasn't forgotten there's a switch there. And what else does he say? Oh yes, he says the mic needs a plug on it. So there's the mic, and as you can see, it needs a plug on it. Now, there's a problem here, and that is that there's water in that cable. Let's just zoom in. Now this lean is short enough as it is, and the last thing I want to do is to chop some off. I'm going to have to chop some off just to see if we can reveal a bit better. But that black wire, the conductor is actually black because of water ingress, and the blue one's not far behind, and it just isn't going to solder. And if it is, it's going to fall off, and then he's going to say that I'm a lousy engineer. So I'm going to have to cut that off. It may be like this the entire length. It happens. Those cutters are too precision. Let's go for some less precision ones. And I'll just zoom back out to the normal position. I don't know whether to use the cutters or use a knife, just to nibble at the insulation. By the way, we don't do mic repairs, but as being a trade supplier, we expect the shops to do the jobs like this. But of course, when you're dealing with an end user, it's no shop involved. So what I've done is to print off the circuit diagram of the microphone from the circuit provided in the back of the handbook that originally came with these. And it's a bit lousy because it's blown up from an A5 size document, but it's quite clear the circuitry in there, how it works, and we can see straight away, because the pin numbering on DIN plugs is quite interesting. Pin 1, pin 3, pin 2, pin 4, pin 5. So as long as we put those to the right ones, and if you don't know the origin of this, when DIN plugs happened, was it probably the 50s, probably early. I mean, it's German, isn't it? But I mean, I wasn't born till '62, but I was seeing them on 50s equipment, late 50s equipment of European manufacture. And so when it was mono, say for tape recorders, you've got record and playback, and I forget which way round it is, but your 2 is the ground in audio, and 1 and 3 are record and playback respectively, whichever. I'd have to look that up. So when stereo came about, they filled in the gaps with pins 4 and 5, and so that's why it started life as a 3-pin DIN, and it changed to a 5-pin DIN, and that's why it's a funny numbering system. But anyway, we've got these super high quality Rian connectors which we buy. Those plastic ones are so lousy. You kind of go from 25 pence DINs to £4.99 DINs, but there you go. This is where you throw away the packet and discover you left a component inside there. So we've got gold plated pins. I should really have threaded the boot over this first. I may end up having to put some lubrication on there. as a church organist I've got quite strong fingers, so we've managed. So what have we got here? This video is going to be more about putting a plumbing plug on than it is doing the radio. So what we know straight away from here is we know the audio is going from the microphone is going to be the white wire, because that's the one with the screen surrounding it. So that's one I'm not going to have to buzz out. Now, shall we use my fingers to do the stripping, or shall we use... Oh, there's a piece of braid that got away. And I'll cut that off rather than try and twazzle it round. There's a good word. So I'll just pluck off the end of the... Yeah, I can see copper there, which is better than the... Still black. We're going to be struggling. I looked at the lady in the bank yesterday, and she got these glued on accessory fingernails in some wonderful, I think it was shocking pink. And I thought to myself, how on earth would she play the church organ with fingernails poking out like that? And how would she use them as wire strippers when putting microphone plugs on? I must put that to her next time. So we want to tin these. I ought to wait till Mark comes, because when the lockdown ends, he solders leads all day. That's his day job. Well, it has tinned. So we'll get our handy jig out. So I've run this circuit diagram. I wouldn't normally do mics on a video because, you know, the information is readily available. I'm not sure it is readily available on these. So we have got the microphone so ground's going to 3. So the microphone hot is pin 1. So we've got the microphone straight through, doesn't go past the transformer, and if the switch was in TX, then it goes to pin 1. So we can put the white wire on pin 1. Now, that diagram is mirror image. So they've done the diagram as if you're looking at it from the pins, which is not the conventional way of doing it. So we've got to wire that mirror image. So pin 1 is definitely my right, held like that, and so it becomes my left. No wonder nobody can wire these mics. I think we'll start by tinning all these pins. So that's our white wire on. So the loudspeaker becomes a loudspeaker in receive mode because it's going through, well, on transmit, let's have a look. It's going through this transformer, isn't it? So in receive, it's going to pin 3. So the loudspeaker goes to pin 3. So what colour wire is the loudspeaker? Well, we don't know. So we'll get the impedance meter. So I'll go on the ground. We could solder that on. I'll need to get my sleeving out for that. Well, I don't think it's going to be the red wire, because chances are it's going to be transmit, and I reckon blue's going to be receive. So what I'm going to do, I'm going to put it on that black wire, the pesky black wire, and we'll see whether that is speaker. Interesting, I'm not hearing anything. Right, we'll do some more rudimentary checks. That's my theory blown out of the water. So we'll take that off, and I'll go between the red wire and ground. Oh, so it looks to me like the red wire is speaker. How bizarre is that? So does that mean that the black wires receive? And does that mean therefore that the blue wires transmit? No, I can't quickly work that one out. Either something's open circuit or I'm losing the plot. So we'll open the mic up. He said the mic may not even work, and of course it may not. These mics are like rocking horse droppings. There's plenty of the 77805 radios around, but not the mics. I mean, I think I paid 15 quid for a faulty mic just to get mine going, and some of these threads are stripped. So we've got the speaker which doubles up as a mic, which isn't always ideal. Then there's the matching transformer to enable it to do that, and then you've got the switch. So looking at this, what have we got? What on earth have we got this green wire going nowhere for? I think it's being got at, to be honest. I think half the problem is it's had screw. And I'll pause the video and I'll see if I can find ours. So a few hours later, I've done a few jobs in between. We're back to this. I emailed the customer and I said it would help me a lot if you email me a picture of another microphone. Now he's got several of these radios. Now he's done just that. So when we look at this, we've got white and yellow and nothing. And the red that should be there, where is it? You know? Well, the green is on its own. Well, it can't possibly be a changeover contact as it needs to be. This is a 4-pole double pole switch. So I'll just come in a bit so you can see what I'm on about. So you've got 4 switches in one unit. Now normally on microphones you have a double pole, you've got 2 switches, which you switch the transmit and receive over, and you also switch the microphone audio through. So that's your 2 switches. But in this case it's switching between the speaker being used as a loudspeaker and the speaker being used as a microphone, and then going through a matching transformer. So you have your changeover contacts for the transmit and receive, and then you've got this arrangement to change the impedance through that transformer. Now, so he sent this. He sent 2 different ones. So the green is there, but where's the black? So we're going to have to do some wiring correction. He's also got a copy of the service manual, which is more than we have. He said he'll get one in the post to me. And this is fantastic because we've got everything that should be there. So we can just work from that. That's excellent. So you've got that matching transformer, you've got a capacitor. I'm going into all this detail because these microphones on their own are like hen's teeth. And this might help somebody even make one themselves out of a readily available plastic box and putting their own works in it. So I've got probably about 7 of these sets in stock with no mics, and that's fine. You mean you can use them with an ordinary mic, but then you've lost the ability of them being having the speaker mic and being portable. So I'll get to go together and get wiring this up. Okay, so we've got the radio on the bench in a normal manner, and I've put the mic back together. That's wired as that diagram shows, and I've not put the boot on the plug in case I've messed it all up. But the white wire, because it needed reassigning at the other end, didn't end up on pin 1. So that's now done as the diagram, and hopefully when I switch on, hey! And when I press transmit, yeah, got an LED out, it actually transmits. So we'll put picture in picture on so you can see that happening. And what we got on high power, we are doing 800 milliwatts, and on low power we're doing 100 milliwatts. Wonder why that is. Okay, well this has all changed. Upon delving into this customer set, it's not repairable. It's receiving nicely, it's transmitting at 1 watt, which is pretty lousy and needs investigation. But the thing is, there's never going to be a display because the printed circuit board at the front is actually broken away from the main board, and what that means is that because these are, you've got it buttered up at the front. I've had the front off this. I'm not gonna. We'll probably just peel it back a bit to show. It's soldered here and it's soldered there. Now these printed circuit boards are made of synthetic resin bonded paper, and lots of cheap consumer products are done this way. And the CB radios at the moment have gone down the better route of fiberglass boards, and less prone to this happening, though it still can happen. What's happened is, at some time in its life, it's been dropped, and whatever it's been dropped on, a corner's hit one of the LEDs, which are flush. Let's look at the one I've got here. So it's dropped, it's hit on one of those LEDs on a corner of something, and it snapped the board. You know, I can't write to Midland and say, you know those sets you sold in 1987? Well, I need a spare part. It's not going to happen. So it's scrap. So what I've said to the customer is, for a token fee, I'll issue one of our sets, which is on my shelf, one of our own we've bought in over the years. And I said, if I put your case, because his case is in lovely condition, the only difference is, his is the D version, and mine is the UK version. Actually, this version is better. The one he's got is slightly newer and cheaper. Now, this has been labelled by Mark as non-working. And straight away, we can see that mine must have been dropped on its switch, and it's broken the switch. So what we'll do is we'll have the switch off the customer set, and we'll put it on mine. So if we put these side by side, you can see they are different. The VCO on the customer set is there. VCO on mine is there. You've got more coils and adjustments on my set. You've got more transistors, but in his set it's later, just because microchip, which replaces about 5 in the receive. So there is a difference, but whether or not it makes any difference is immaterial. This needs sorting out. So I'll do this, and then we'll see whether we can power it up. The other thing is that my set's got a normal channel switch and then probably an LC7137 IC, and the customer set has got the C121 whatever it is, which starts off on channel 9, and it just has a rotary channel encoder, which is actually an up and down switch. That's all it is. So this is one of those sets that starts off on channel 9, which is very annoying. So hopefully this will be more suited anyway to him. So we're going to power it up. I'm not mounted the switch because we don't know which is on, which is high and which is low. The wiring is different colours to what was on the other one, so it's all guesswork. This one's manufactured 1990. What does it say on the back of this? It says diddly squat on the back of this. It says made in Thailand. What's it saying on mine? Made in Thailand. Right. Okay, so we're powered up. So that's working, which is more than was on his. We've got no audio on receive. Let's see what happens on transmit. Well, the great news here is we've got some decent power. We've got 3.1 watt before we start, so that's another improvement. Now, whether we've got any transmitted audio, 1 2 1 2, testing 1 2 1 2 1 2. We have with the customer's mic, so that's good as well. So, what shall we start doing? Oh, so we're obviously in high power. So if I turn that switch to there, we should be in low power. We are. So that means I can mount that switch. And then that has to go in that little thing there, to notch there, to stop it turning. It wants to do everything but go in the notch. Yeah, we'll do that in the other workshop. So we'll just go through transmit. Peak. 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 Now then, I can't remember what control does what. Is that transmit power on these? No idea. Or is that on low? Is that low power on these? It is. So we actually want 400 milliwatts, but really we can't set that until we've set the main power. So I will just set it. There we go, 400 milliwatts. There is a power control if I remember rightly. Doesn't matter what I upset on this, because we're going to be able to set it back with the test equipment we have here. So we'll just make a note that I'll just do this, then we'll come back to the video. Okay, I don't think this version has a power preset, so we'll just do these. It's never been messed with. It's always nice when they've not been messed with. It's about 3.4 watts. And there we go with full 4 watts. Just check that's in balance. Spot on the 4. Good. It's better than the 1 watt on the set he was using, and I don't know, it was drawing a lot of current considering. I mean, this is drawing 1.05 amps, and his was drawing 1 amp, but still only doing 1 watt. So the power was all going somewhere, so I dread to think where it was going, but I think there was a coil which was, this has got different shape coils, but the equivalent to that one I think was malfunctioning in his. So that's another issue. Anyway, we've still got no receive on this. We've got receive, sorry, we've not got any audio on receive, so we're going to probably have a faulty IC or something. So it's not all straight plain sailing. All I've done is to replace that switch, and we're doing a basic tune-up. So we've got the 4 watts on it. We'll just check the meter when we key up says 4, it does, but we'll just make sure that it says it correctly So I'll key it up. Wrong tool, use that one. So it wants to be just on the 4, and then when we switch to low power it should be 1. It is. So that's now set right. We want the deviation to be right. Testing 1, 2, wallow. I'll make sure that sounds okay on our receiver. Hello, testing 1, 2, testing 1, 2. Testing 1, 2. That sounds absolutely fine. It's nice to see his microphone working. So, what does that leave us with? So we don't need to touch deviation, it's spot on. And deviation would be that one there. So let's make sure it's on frequency. Okay. I'm going to put the meter away, even though we haven't got any audio on receive. If it's the audio IC, I'll simply take the audio IC out of his set. You know, it's a no-brainer. So, what do we have to do on here? Press that button. So we're looking for 2779125. I mean, that's spot on, isn't it? I'm going to just touch it up that little fraction. There you are. It's now 28. Want to be very, very slightly high because they drop with age. So that's on frequency. So it's clearly receiving. As I turn the signal generator, we can vary the signal on that channel. If I change channel, we've lost the signal because it's no longer on that channel. So we know that the radio is receiving. We just can't hear anything. So it should be coming through the speaker mic, and it should be coming through, or it should be coming through the speaker mic while I unplug that. It isn't. And I can't feel anything's getting red hot just there. So we've got something wrong. So I'm going to turn the power off. We'll pause the video and I'll take the bottom lids off. So taking the audio IC out, we can lose picture in picture now because we're not showing you anything of that. We've got a heatsink here. It's bolted to this power regulator transistor, so I've had to take that out. There isn't a, on this type, there isn't a insulation kit. So the only way you'd get to that screw, because otherwise you're going to be doing that, wrecking that capacitor. It's just not going to happen. So we need to now, I've unsoldered the IC, so hopefully we can actually pull this out there we go. So we have the IC on its heatsink, and I can't think we're going to have any other malfunction which is going to cause no audio whatsoever. But I'm just looking at that capacitor there. Is that glue? Yeah, it's not shot its load, it's glue. Just look, there doesn't seem to be any damage to any capacitors in this. So it's KI. Oh, it's got a hole in it. Yeah, it's blown up. KIA 7217. I'm sure we've got one of those lurking on here. No, it's not one of those. Well, hopefully the one in his set's the same. Yeah, well, we'll take that out and now they haven't got the power regulator on this one. It's the same part. It's still got the hole as if it had the power regulators. They've not changed the component there. So I think we can really do this the easy way and just pop this out. I won't even need to undo it from the heatsink if it's the same part. And we know this works on receive. So normally we'd use totally new parts, but you see, we're going to sell this customer our set for some token amount, like a tenner. So we're going to charge him for the service work, but we're not going to charge him for parts because we've taken them off his set. So that's sometimes how we can do things really cheaply. So I'll just unsolder this. Okay, so spot the next pitfall. Well, we've got the two out. That's the Duff one in my right hand. That's the one out of the customer set in the left hand. But look, pin 1 is to the left on the customer's one. Pin 1 is to the right. It's actually back to front. So we're going to have to mount this the other way around. And you can imagine somebody not noticing that. And this can be the pitfall, even though they're on the face of it the same set. So we're going to have some right fun taking that off, so we'll pause the video. Okay, so that's now changed it round. So we've now got pin 1 there, and there's the customer's existing one with a hole in it, pin 1 there. So they're now identical. And they're both Kia parts, so that's they're the same number. So there we go. What I tend to do when they come out of a set is just to file the pins, because although we've unsoldered them, what I don't want to happen is for there to be just that little bit of solder that's enough to break away the print. They're not good printed circuits in any of these consumer type of products, and CB radios are most definitely not an exception to that. It was dreadful when I was in the telly business, and you know, you got that heat generated from tellies, especially in the days with valves in them. In America, that's tubes. In England, tubes means the cathode ray tube. I haven't had a television in my house for 20 years. If you think I'm paying towards BBC's ridiculous wages, I'm certainly not. I can make my own TV programmes, can't I, doing rubbish like this. So I think that's cleaned up nicely. And now all we need to do is try and put that so all the pins go through the holes. Just before I do put this together, there is a good trick here when you're putting second-hand parts especially in, and that is to put them in from the easy side, just to make sure that the pin spacing is still how it should be and the holes are cleared out just as they should be. So I've now put that in from either side, so hopefully when I offer it up from the correct side, it should just fit. So that's gone straight in, and now what we'll do is we'll put these screws back, because the last thing you want to do is solder it while it's not mechanically held in. Imagine the situation where you've soldered it, these don't quite line up, and then you're putting mechanical strain on the soldered joints, and once again we've got that problem with the inherently weak type of printed circuit board that these radios use. So now we'll put that power device back in. Go in the next workshop and put the spanner on this, but I think we can hold that nut sufficiently with those pliers. If not, we will go next door. Nope, that's fine. So I just need to solder that up, and then the moment of truth. I'll go over this without isopropyl alcohol later on, but I think we'll do it now. Really need to solder the pins as quickly as possible. It's easy to destroy any of these semiconductor devices by overheating them with the soldering iron. Then I can inspect it better because there's no flux. I don't think they're that cheap, these ICs, especially the Kia version. Bit of corrosion there, we'll deal with that. Apart from that, the board is nicely washed. You know, a lot of printed circuit boards we see aren't washed at all. Of the flux is what I mean, and you know, these are nicely done. So I'm going to get a magnifying glass at that. So that looks to me to be spot on. Right, now for the moment of truth. I'll make sure the volume's down in case it suddenly bursts into life. Got a bit of a dirty volume control, we can deal with that. That's what we want to hear. So what I'll do with this, because I'm going to put the heatsink in the scrap box, I'm going to cut the pins off the IC so that it doesn't accidentally get used. You can see the logic there. Good. So we'll go through the receiver. Yep, it's coming through his speaker mic as well. So start off, we've got S9 on the... I'll go back into picture in picture and we'll put the... And we'll see whether the detector needs adjusting. I don't think there's going to be anything wrong with this. It's simply been blown up. Somebody's either shorted the output out or overvolted it or something really silly like that. Now the detector's pretty well hidden in the wiring. It's just there. So we'll just do that. Very minute improvement. Tell you what, this is receiving superbly. Let's switch the cyanide meter on and get on with it. So that's 0.3 of a microvolt. Oh, using the metal tool, no wonder it's varying. Let's do that with a bigger signal. That's it. .49 of a microvolt, 0.49 microvolts for 12 decibel cyanide. Actually, it's better than that. I've got 0.47 microvolts. So let's look at 20 dB. I'll tell you what, it's 1 microvolt for 20 dB, and it's 0.41 microvolts for 10 dB. So that's working fine. So we'll now put S9. I'll put this on the attenuator controls, and we've now got S9 on there. So I want the meter to read 9. And hey presto, it actually does read 9. Which is the RX meter. I will just point that out. It's the second one down. So there we go. We can make it plus 30. So we'll just see where we are on the meter. Yep, get all those to light with the signal generator's attenuator. Now we'll go to the squelch and turn the signal generator to standby, put the squelch on, advance it to full, put the signal generator back on, and I want that to come in, if possible, at 100 microvolts. It doesn't, so which is our mystery control for squelch. We've done RF meter, we've done receive meter, we've done low power. We know that's deviation, so that must be the squelch down there. It is. There we are. Yep, that's coming in exactly where I want it to be, S9. So at the other end of the scale, we'll turn that to minimum, signal generator off, set threshold, switch the signal generator on. It's already in. So our sensitivity is coming in at 0.3 microvolts, dropping off at 0.2. It's a good sensitive squelch, ideal for listening to people round a scratchy corner. So that's it. So you can see this is an untouched set. It was just broken. Broken switch through mishandling in some way. Broken IC because some Wally's done something stupid. We got another one of these, which I could have. We've got a choice of two, but the other one I got a bit more ropey front, and you can't. I think these are moulded in. I don't think there's anything you do about it. So I'm just going to clean this volume control, hopefully. At the end of the day, it's still a 30-year-old set. There we go. So now we'll put his cases on our set. Just need to tighten that up. Okay, so that's screwed together, put back together. His cases, our radio. One on the Roger. Okay, so there's about 3 conversations, each about 30 miles away. And of course it's got the on and off for the displays, because with it being a portaback you need to be able to save battery consumption. And if I just show you, I'll tell you what, no, we can't do that really. I was going to say we'll put the signal generator on, but I've disconnected it. I'll see if I can just pick up channel 20, which is what we were on. No, I can't. So go back to 19. What I was going to say is, we'll tell you what the consumption is. At the moment, it's 150 milliamps. If I turn the squelch down, still 150 milliamps. 160 when you talk. So if I turn the lights off, it's now only 100 milliamps. So it takes a third of the power away, which is great. And it's 1 amp on transmit on high power, and let's look what it is on low power. It's 400 milliamps for 400 milliwatts. Okay, we're doing on the air test with that with Mr. Chippy. I'll just make sure it's sounding. I'll just change the channel to 20. I'll put it on low power so as not to annoy anyone. We'll just listen on our monitor receiver. Testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. That's fine. Good. Oh, you will be chuffed. Thank you for watching the Midland 77805 UK and now a scrap 77805D UK.